All right, so I promised you in this video we're going to solve more molarity problems, and we left off with just basically an example that said we don't have to calculate molarity every time. At least one part of the puzzle could be missing. It might be molarity, or it could be volume, or it could be the amount, right? As long as I know two of the pieces, then I'm good. So molarity is equal to mole divided by liter. So we're going to do our next example. And this example says, well, calculate the mass that's needed if you want to make 750 milliliters of solution and you want a strength of 2.50 molarity. And we're using sodium chloride here in the preparation process. All right. So I want a 2.5 molarity NaCl and I need 750 milliliters of it. So here's what we do. Molarity, volume, mass, or an amount. The only formula that relates those things together is the molarity formula, M over L. Well, I know the molarity. It tells me that in the problem. 2.50 is the molarity. I also know the liter. Right? Now, this gives me milliliters, so I'm going to have to convert that. When I do that, I'll take 750 mils over 1. I need to go from milliliter to liter. There's 1,000 mils in a liter. So 750 divided by 1,000 is 0.750. So that goes in for L. And up on top is M. That's what I'm after. Now, I know that this equation is going to give me M, which is mole, but once I get mole, I can then go to mass by using the formula weight, right? That represents the amount of stuff. So that's what I'm going to have to do first. I'm going to have to solve for mole, get an answer, then do one extra little step to go ahead and convert that on over to a gram. Okay, so I'm going to bring up the calculator. I'm going to take 2.50. I'm going to multiply by 0.750 and hit enter. And I get 1.875. So M, which represents mole, 1.875 moles of NaCl. That's telling me how much I need to weigh out, right? But the scale does not weigh out moles. Sorry. The scale weighs out gram. So I need to be able to take that mole and convert it to gram. So mole to gram, gram to mole. I need formula weight in order to do it. So one more step. 1.875 moles over 1. Mole on top, mole on the bottom. I need to get to gram. Well, how many grams are in a mole of sodium chloride? Well, I need to be able to do formula weight here. So sodium is 22.99, and then the chlorine is 35.45. Whoop, 35.45. And that gives me a 58.44. So 58.44 grams for every mole. That's the formula weight for sodium chloride. So there's gram, 58.44. There's mole. There's a 1. So now in order to solve the problem, I'll take 1.875 and I'll multiply that by 58.44 and I'll get 109.58. And that's how much I would have to weigh out and dissolve in 750 mils to make that strength of solution. This is a very common process that lab technicians have to do. They have to be able to go through, make a solution. We need this amount, volume-wise. We need it this strength. So how much do we actually weigh out? This is probably the most common type of scenario that you will experience in a laboratory. Bottom line, right? You got to be able to do the molarity equation in this form. It's probably the most important form that you will see. So here's the strength. This is how much we need to make. So you go figure out how much we need to weigh out in order to make that solution. That's what this is all about, right? I'm not focused on significant figures. If I was, we probably would round this to 3 numbers, and that would be 110 grams. But that's not the purpose here. That's for chemistry 151, 152. I want you focused on the process. Don't get tangled up in all the details. I want you to understand the process of the equation, where the numbers go, and how to solve it. All right, so let's do another example. We're going to clear off this screen and do our next one. What mass of silver nitrate, AgNO3, is needed if we want to make 2 liters of a 0.100 molarity solution? Okay, molarity, volume, mass. The most common type of example with molarity here, right? So I'm going to start off with my equation, mole over liter. I know the target concentration. We need a 0.100 for the lab, equals. I don't really know how much. That's what the question's after, so that's going to stay as an M. But I do know volume-wise, 2 liters of it, right? So, good. Liter is required on the bottom. It's already in liter. Don't have to do nothing to that number. So a 2 goes there. All right, so to solve for M, I'm going to multiply by 2 on each side, right? That gets rid of that. That leaves me with a little m over here, and 2 times 0.1 is 0.2. All right, so that tells me the number of moles of AgNO3 that I need. But the question is mass. Again, my balance cannot weigh out moles. My balance weighs out grams. So I need to be able to take 0.200 moles of AgNO3, and I need to be able to convert that into a gram. And I can do that if I know formula weight. That's why we started off with formula weight in the very beginning of this course. It's probably one of the most basic fundamental staple calculations that you can do. All right, so in order to do that, we need to know more about silver's weight. This is kind of uncommon. We don't use silver a lot. The nitrogen we've used, 14.01. The oxygen we've used, 16 even. The silver, though, is kind of rare. So we need to pull up the periodic table. So here's another version of the periodic table, a little bit different than what we've seen. I like to keep giving you different versions of it so you can kind of get comfortable seeing this information in multiple ways. But we need to look for silver, and silver is Ag. I know I've cut off some of the periodic table, but that part you don't need. So we just need to look for Ag, and right there it is. Ding, 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 ding. It's at number 47. That's the atomic number. So up here at the top in the key, you'll see the bottom, or the top left in this case, is the atomic number, and it looks like the number right beside of that one that's not bolded, that is the atomic mass. That's what we're after for formula weight. So silver is atomic number 47, and its mass is 107.87. That's a whopper, right? Compared to some of the others that we've been doing. So 107.87, that's what we're after here. So I'm going to bring up the calculator. 107.87 plus the nitrogen, which is 14.01, plus 16 times 3. So you can enter it in that way, or 16. There's my second oxygen, and there's my third oxygen. So the formula weight here is 169.88. So 169.88 grams for every 1 mole. That is the formula weight for silver nitrate. Okay, so I've got my mole, brought in formula weight to try to get gram. I now need to finish out that calculation. 0.2 moles times 169.88 equals 33.976. So we're going to round this off. We're going to round it to 33.98 grams of silver nitrate that I would need to weigh out on a scale and dissolve in 2 liters. Mix it up, make sure it's completely dissolved, and now I've got my 0.1 molarity solution. But sig fig wise, they'd probably want you to round it off to 3, so this would go to a 34.0 even. Again, who cares about sig figs for now? Look at your process, make sure that you understand how to solve these. All right, let's do another example. One after another after another. I know you love it. How many milliliters of a 1.50 molarity sulfuric acid solution can be made using 36 grams of sulfuric acid? So if I needed 1.5 molarity and I only had 36 grams of stuff to use, what is the volume that I should be using? That's what this is after. All right, so here, molarity is equal to moles per liter. The molarity, 1.50. The mole, well, I'm going to get, right, eventually. That's where this gram is going to come into play. And it wants to know how many milliliters. So I know that L is going to have to stay as an L. That's what I'm trying to find, right? Okay, so 36 grams over here, we need the formula weight for sulfuric acid. We know we can go from gram to mole, which is what the equation needs. It needs mole. I know I can do that if I have the formula weight for that compound. So I'm going to bring up the calculator. Hydrogen is 1.01, and there's 2 of them. So I'm going to add another one. My sulfur is going to be 32.07. And then my oxygen, there's 4 of those. So I can do 16 times 4 and key it in that way. Or there's my first one, there's my second, there's my third, and there's my fourth. So 98.09 is the formula weight. 98.09. All right. I'll write up that here to the corner, gram per mole. So I've got 36 grams of sulfuric acid. Gram on top, gram on bottom. I need to go to mole. This formula weight says there's 98.09 grams. Well, there's my G. There's gram. So 98.09 per 1 mole. So a 1 goes there. So I'm going to take that and I'm going to divide those 2 numbers. I'm going to take 36 and I'm going to divide it by 98.09 and I'll get 0.367 as an answer. That's how many moles that I'm using to make this solution. So in this equation, 367 is going to go there. Now, I need to solve for liter. I need the volume. That's what this question's all over. So I need L by itself. So I multiply by L because that's divide by L. I do the opposite of. That way it can cancel out. But if I do one side, I got to do the other. So 1.50 times L is equal to 0.367. 1.5 times L, I need to get L by itself, so I need to get rid of that number. That's multiplication, so I'm going to divide, and I'm going to divide by 1.5. So L is equal to 0.367, right up here on the screen, divided by 1.50. I hit enter, and I get 0.24, and I'm going to round it up to a 5. 0.245. Now, that's great, and if you left the question here, you'd get it wrong. And the reason is because that is volume, and that volume is in liter, right? That's how the molarity equation is written. It's in terms of liter. But that's not what the question wanted. What the question wanted was how many milliliters could you make? Well, you've not answered the question yet. You're almost there, but not quite. So to get your cookie, you need to convert this over to milliliter. All right, so if you need help on doing that, 0.245 liter over 1. Liter on top, liter on the bottom. I need to get to mils. Millennia, there's 1,000 years, so 1,000 milliliters in a liter. So 0.245 times 1,000, that is what you need. So milliliters is going to be 245 mils. And that's the answer to the question. So folks, that's all there is to molarity. I think if you can do these examples and you feel comfortable with these, no matter, as long as you've got 2 pieces of the third of the 3 that's required for the equation, I think that you can solve for the other one. We've done a couple of examples of each, right? So if you feel okay with these, I think that you'll do perfectly fine on the assessment that happens after the videos for molarity. So quickly review, make sure you have your calculator and a periodic table handy, because you'll probably need to be doing some formula weights in these questions. And if you do, good luck, but of course you don't need it. You're going to blow me away and you're going to make me feel like I'm not even needed anymore, right? You could do this job.